Hello, let's talk about descriptive statistics. Descriptive statistics deals with the collection and presentation of data and the summarizing values that describe the group's characteristics. The most common summarizing values are measures of central tendency and variation. When we say measure of central tendency, that refers to the mean, median, and mode, while variation refers to the range, variance, and standard deviation. Measure of central tendency is commonly referred to as average. That value is represented in a data. There are three types of measure of central tendency. We have arithmetic mean, median, and mode. Arithmetic mean, and average are just the same. Mean is denoted by x bar or x to the bar symbol. It is just simply as the sum of the data values or the summation of all data values over the total number of data values and how many samples are there. Let's have examples here. The test scores of the students in the latest prelim exam. There were 45, 41, 38, 50, 26, and 48. To find the mean, it does not matter the arrangement of data, but we are just simply adding them. 45 plus 41 plus 38 plus 50 plus 26 plus 48 divided by the total number of data, which is 6. That is equal to 248 divided by 6 equals to 41.33, and that is our mean. For our median is the data or the number of data that is separated into two equal parts. When the number should be arranged from at least to greatest or from greatest to least. In median, it does not matter the arrangement of data because since then we're just simply locating the median. Okay, so regardless whether from increasing value or decreasing value, still we're just simply locating the median. But we have to be sure that we arrange them properly, whether decreasing or increasing. Okay, let's say for example, let's use the example data. Okay, we have 45, 41, 38, 50, 26, 48 from our previous example. So let's arrange them properly. So let's start with the smallest value. We have 26, 38, 41, 45, 48, and 50. So simply as if you're going to find a median, we are just then locate the position or the location of our data, okay, in which it divides the whole data into two equal parts. We have 3 here and to your left side, we have 3 here, another to your right side. So that divides them equally. So to find the median here is just simply because it is in between your 41 and 45. So we're going to sum them up and divide it by 2. In which is, in this case here, our median equals to 43. What if you are going to add another value here of 50? So let's add another 50 here. Instead of 6, we have now 7. So to find then simply, okay, if we are going to divide them equally, identify that our median here is at 45. Next, mode. A mode is a set of numbers that value occurs most frequently. It repeats. We have different kinds of mode. We have unimodal, bimodal, and multimodal. When we say unimodal, okay, let's describe them by using samples of data. Now in this case, we have 26, 38, 41, 45, 48, and we have 250. That is unimodal. It is considered as unimodal because we have one mode here that is equals to 50. The value of our mode is 50. Okay, in bimodal, we're going to have two values, okay, that equal, okay, the same number. Let's have, for example, we have 48, 48, and another 50 and 50. They have equal numbers. I mean the numbers of values such as we have 248 and we have 250s, okay? that is they equal to the modes of 2. So we have now identify our modes here as 48 and 50. It doesn't matter if how many values, if as long as they have the same value for bimodal. Okay, just like for example, okay, in unimodal, if there will be 350s here, 4 or 150s, the modes here, the modes there will still be 50 because it is the most frequently repeated number. Now in this case, let's say for example, for 48, we have 348, we have 350s, then that is still bimodal because we have the same value that is at 48 and at 50. But if only 50 is 3 values, but say 48 is 2, then that is, we call it, that is considered as unimodal. Unimodal because we only have, okay, the most frequently repeated value or number is 50. We have 350 if we are going to add 50 here. We call that unimodal. Okay, if it will be more than 2, then we call that multimodal. Okay, just like in this case, although we just have 2 of 41 here, another 2 of 48 here, another 2 of 50. Okay, so that is more than 2, that is 3 already. It does not matter if it will be, there will be 4, 5, or 6 the same value or number that repeats, but they have the same value of number that repeats, then we call it multi-mode. Okay, but if in this case, if we're going to, if this sample, we're going to add another 48 here, so that can't be called as multimodal. It will be unimodal. Okay, because 3 of 48 is more than 1 of your 41, which is 2, and more than 1 of your 50, which is 2 also. So we have 348. If we're going to add 48 here, then it will be, our mode is 48, and it is, the type of mode is unimodal. But in this case, for multi-mode, we have here identified that 41, 48, and 50 are our modes, okay, in which is considered as multimodal. If there is none, then if there is no number that repeats, that means, okay, there is no mode. Let's have fractiles. Fractiles are measures of location or position, which include not only the central location, but also any position based on the number of equal division. Take note, class, the equal division here of a given distribution should be considered. It must be equal, divided equally. There are 3 most commonly used fractiles. We have quartiles, deciles, and percentiles. When we say quartiles, we're dividing them into 4 equal parts. When we say deciles, from the word dc, that is 10, we divided them into 10 equal parts. At the same time, when we say percentiles, we are dividing them into 100 equal parts. Okay, let's have them quartiles. When we say quartiles, again, we're going to divide the distribution into 4 equal parts. Let's say, for example, this given, we have 45, 42. It decreased and decreased and decreased, but it increased. So these numbers or data is unarranged or not arranged properly. So what we're going to do first is that we're going to arrange them properly here. The smallest number value, 28, 36, 36, 37, 42, 45, 46, and 49. In which, in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 data samples. So for quartiles, okay, whether quartiles, percentiles, or deciles, it is advisable that the next step after you arrange your data is that to find the median. Okay, in order to divide them properly. That means we divide them equally. Okay, after we divide them equally, so let's divide here to your left and equally here to your right. That means we divide them now equally into 4 equal parts. We have 2 here, 2 here, 2 here, and 2 here. Okay, in quartiles, that means we were just then slicing them into 3. Diba? Right? Right? We were just slicing them into 3 times. Okay, if we are going to divide them, if we are going to divide them into 4 equal parts, we are just simply slicing them or dividing them into 3 times. Like here, 1 slice, second, and third. So this is our Q1, this is our Q1, our Q2, our Q3. The formula for this is just simply, this is 25% or 1/4 of your n. And this is 1/2 of your n actually, but if for the sake of data presentations well properly, this is your denominator should be equal to 4, but this is the second, quartile 2. So that is 2n over 4, or this is just simply as n over 2. 1/2 of your n of the total number of data samples. And your Q3 here, we have 3 or 75% or 3/4 of your n, where our n there is the number of samples of our data. So again, we have n 8 here because we have here 8 values of our data, 28, 36, okay, another 36, 3, 4, 5, 6, 7, and 8. That is our n is equals to 8. So to find the position or the location, so this is now the solution. Substitute the value of n, 8 here. So divided by 4 for our first quartile, that is equals to 2. For our Q2, we have 2 times 8 divided by 4 is just simply 8 divided by 2, that is equals to 4. For your Q3 here, we have 3 times 8 divided by 4, that is equal to 6. So this is the position, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, again, the position or location of our Q1 here is at 2. And the location or position of our Q2 here is at 4. Okay, and the position or location of our Q3 here is at 6. Okay, but if we are going to find the value or the values of our Q1, Q2, and Q3, so that is now then we're going to find specifically or the position or location of this value, and which is in between the two values of 36. So that is then if you're going to add them, 36 plus 36, that is equal to, that is still the same if you're going to divide them by 2. That is still, our Q1 is 36. Our Q2 here will be then 37 plus 42 divided by 2. That is actually 39.5. For our Q3 here, Q3 will be 45 plus 46 divided by 2. That is 45.5. Okay, how about, let's say for example, okay, in this case we have 8. So how about let's make it 9. Okay, let's add another 49 here. We're going to locate the first, the median or the Q2 here. Q2 is just simply equal to your median. Here, we have n is equals to 9. So that simply as 9, we're going to replace here 9 to our n. So 9 divided by 4, or for Q2 here, there is just simply n divided by 2, or 2 times 9 divided by 4. That is equal to 4.5. Again, 9 divided by 2 is just simply as 4.5. 4.5 is the specific location of your data value, which is actually C42. If we are going to divide 4.5 by 2, okay, in order to have an equal parts of here in your measurement, so it is just simply divided by 2, 4.5, that is at 2.25, which is 2.25 is actually this value, 36. This is not the one, this is not the 36 here, but the 36 here. Okay, and also your Q3 here is it at 6.75. Okay, now we divide them. We did divide them equally. Okay, so because if we are going to replace here your n divided by 4, that location or position is at 2.25. If we are going to add another 2.25 in order to have the same range, so it will mean now that 4.5. If we are going to add another 2.25 to 4.5, that is equal to 6.75. If we are going to add them another 2.25 to 6.75, that is equal to 9. Okay, this is the solution here, Q1, Q2, and Q3. So we have here marked the specific location. Okay, take note class, it doesn't mean that your value here, when it is in between your 2 and 3, that is already 2.5. No, because we are referring to the distance 9. Okay, because if we are going to divide here 9 to the distance of our quartile divided equally, that is specifically 2.25, not 2.5. The same as here, but in this case, although you have your in-between values of your 4 and 5, it is 4.5 because if we are going to divide 9 by 2, that is still 4.5, which is that value is 42. The same here, if you are going to add again 2.25 to 4.5, that is the position is at 6.75. Okay, and again, if you're going to add another 2.25 to 6.25, it will be equal to 9. Okay, and that means that we divide them equally. For decile, so we are just simply dividing the distribution into 10 equal parts. In this case, with example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 data samples. And this is an arrange. So we have to arrange them properly. 10, 11, 12 now. Okay, 17. This is the position, D1, D2, D3, D4, D5, D6, D7, D8, and D9. When we divide them 10 times 10 equal parts, that means we will just slice them into 9 times. So there will be only, for this size, D1, D2, D3, D4, D5, D6, D7, D8, and D9. Okay? So this is the formula. Actually, this is generic formula for quartile, percentile, and decile. So if for quartile, you just replace your D with Q and replace your denominator with 4 if it is Q. But if for percentile, you replace your D with P and you replace with your denominator with 100 because you will be solving for percentile. Now for decile, then this is 10 because this is decile. We were dividing them into 10 equal parts. So let's say, for example, we're going to find D6. Now in this case, it is very clear because we've already identified the location D1, D2, D3 until to D6, but without knowing them, okay, we can use the formula. Later on, we can have values that we were not going to tabulate it. Okay, so D6, simply substitute or distribute the term that we're looking for, that is at D6, 6. Then here 6 times the n or sample data, we have 10 equals to 10. So 6 times 10 divided by 10, cancel 10, that is 6. So this is D6. Now wherein the question here is not specific if what we're looking for, whether we're looking for the location or the value. But before you're going to find the value, of course, you have to find first the location. How you will be able to find the value if you will not be able to find the location? So the first thing that you should do before you identify the value is that find the location or the position of the value. So then, after we identify the position or location of our value at 6, so 6 is here. So it is in between your 14 and 15 data. So we will just be then adding them and divided by 2. That is, our D6 is equals to 14.5. Next, okay, let's say for example, if we're going to find D6, but when our n here, or a number of samples, is 24 now. So let's use the formula. It is just simply as we're going to distribute the term 6 here, and the n, okay, capital N here is 24. That is 6 times 24 divided by your 10, because this is D6. Then it is just simply as equals to 14.4. This is the same with percentile. When we divide the distribution into 100 equal parts, so that means we're slicing them into, how many times we're going to slice them? It is at P99. When we are going to find the term of our percentile, P to the nth, okay? So that is just simply then, let's say for example, let's have find the location. Okay, this is very specific, as we are told, or we are tasked to ask to find the location of P88. If we have 240, we're just simply substituting these formulas, these values to the formula. Your term is 88, so 88 times your n is 240 divided by 100. Your 211.2 here is not the value, but this is the location of your value, of your sample, of your data. Okay, but that value is, we don't know that. Okay, we are just tasked to find the location of the percentile, the term, the 88 term of the percentile. But if we are going to find the value of our 240 samples, now in this case, if there will be many data, then we will not just plot them like this table. Instead, we will just be then simply in online or internet, there are calculators. How are we going to find that value? We don't need to arrange them. We're just simply input them. The computer itself will provide you the value of our data. All the data that we need. The mean, median, mode, and the quartiles, percentiles, whatever what we want to ask for the calculator. Thank you.